Okay, so we have here the diagram shows transmission tower TB of height 25.2 meters, topped with an antenna AT. The point C is 18.9 meters from B, and the angle of elevation is at, and the angle of elevation at C to the top of the antenna is 56 degrees. So here we have a diagram, and it says here, calculate, given your answer correct to 1 decimal place, the length of TC. So our goal is to determine the length of TC. Now, where's TC? Well, here is TC. TC is right here. And our goal is to determine that length, the length TC. And so what we have here, TC is part of the right angle triangle. All right, that's what TC is part of, this right angle triangle. And so we have this side already, and we have this side. And so in order to figure out the third side, what we need to do is we need to apply Pythagoras theorem, which says that C squared is equal to A squared plus B squared. Now, we are trying to find TC, and TC is the hypotenuse. And so that means that TC is C, all right? So C is TC. So let's label it, So TC is going to be C, that's the hypotenuse. A is going to be 25.2, and B is going to be 18.9, all right? And so let's use this formula. Notice that we have A is 25.2, B is 18.9, and C, well, that's what we're trying to figure out. What is 25.2 squared? That's going to be 635.04. What is 18.9 squared? That's going to be 37. That's going to be 357.21. So we have C squared is equal to this sum. Next, we're going to add these two. And when we add them, we have 992.25. So we have C squared is equal to 992.25. Next, we take the square root of both sides. And when we take the square root of both sides of the equation, we are doing that because we want to get rid of this power 2. And so we cancel this with that. And so we get that C is equal to the square root of 992.25. And so we get that C is equal to 31.5. And so that means that the length TC is equal to 31.5. That's the answer here. Next, the question wants us to determine the angle BTC. And so we have B, we have T, and we have C, the angle BTC. So they say, calculate, given your answer correct to 1 decimal place, the angle BTC. So we're really focusing on the angle in the middle, right? So we're really we're really focusing on this angle right here, right? So we're zeroing on this angle. So B, T, and C. So we're focusing on this angle, and we're looking at this particular right angle triangle. And so let's label this right angle triangle. We know that that's theta, that's the angle that we're trying to focus on. We know that the angle that is opposite theta is called the opposite side. The angle that is opposite the right angle is the hypotenuse. And the last side, I'm sorry, the side that is opposite the angle is called the opposite side. The side that is opposite the right angle is called the hypotenuse. And the third side is the adjacent side. Again, the side that is opposite the angle is called the hypotenuse, the given angle. The side that's opposite theta, or the side that's opposite the given angle is, and it doesn't even have to be the given angle. It could be the angle that we're trying to find too. So let's just say the side that is opposite theta. The side that's opposite theta is going to be the opposite side. The side that's opposite the hypotenuse, the side that's opposite the right angle is called the hypotenuse, and the third side is the adjacent side, okay? And so we need to find out, or we need to figure out what is this angle, right? This angle in the middle. And so what we're gonna do is notice that we have all three sides. Now, how do we know that we have all three sides? Because we just figured out in the previous question that the hypotenuse is actually 31.5. That's what we just figured out. And so since we have that, we know that we have all three sides because we have what the adjacent is, right? We have what the opposite is, and we have what the hypotenuse is. And so what we have to do, since we have all three sides, we can use any one of these trig ratios. But I want to use the sides that were given. And so I want to use the adjacent side and I want to use the opposite side. So 25.2, 25.2 and 18.9, I'm going to use the opposite and the adjacent side because they were given to us. It's just a safer route. And so we have opposite and adjacent. Okay, opposite and adjacent, that means that we have to use tangent, right? Opposite and adjacent. And so let's use tangent. So we have tan of theta is going to be equal to the opposite over the adjacent. Now, what is the opposite? Well, the opposite is 18.9, right? That's the opposite. The adjacent is 25.2. And so that's the adjacent. So you have tan theta is going to be equal to 18.9 divided by 25.2. And so in order to figure out what theta is, we're going to apply the tan inverse to both sides of this equation. And so we have tan inverse of tan theta is going to be equal to tan inverse of 18.9 all over 25.2. Next, we cancel the tan inverse with tan, and we are left with theta is equal to tan inverse of 18.9 all over 25.2. What is tan inverse of 18.9 divided by 25.2? Well, the answer is 36.86989765. But they want our answer correct to one decimal place. And so we're looking at this 6, and once it's 5 or greater, that means that we can add 1 to 8. And so we have 8 plus 1, which is 9. And so what we actually have is that theta is equal to 36.9. And so BTC, or yes, the angle BTC, right, which this angle, really angle T, is going to be equal to 36.9. And that's the angle right there. Let's put the symbol. So the angle BTC is equal to 36.9. Okay, next we have to figure out what is the height of the antenna. Okay, so they want us to figure out what is this height, right? The height of this antenna AT. All right. Okay, so what we're gonna do is, in order to figure this out, let me just show you how we're gonna do it, like a general idea of what we're gonna do before we actually do it. What we're actually gonna do is we're gonna figure out what is this length, the length AB, right? So why is that important? Because if we figure what AB is, right? What is this length AB, right? If we figure what that is, and we take our answer and subtract it with this 25.2, because 25.2 is TB, right? So if we know what AB is, the whole thing, right? And we subtract that with 25.2, then our result will be AT, okay? So that's what we're gonna do. And so let's do that. So we're gonna figure what is the length of AB. So that means that we're focusing on this big triangle right here, okay? And so if we have this big triangle, we know that. So this is the triangle that we're actually focusing on, the bigger one. And so what does that mean? Well, that means that this is the angle, this is the given angle, and the side that is opposite the given angle is the opposite. The side that is opposite the right angle is going to be the hypotenuse, and the one that is left is the adjacent. We are trying to find out, we're trying to figure out what is the opposite, right? We're trying to figure out what is AB, right? So that means that we're gonna need the opposite side. What side do we have? Well, we have what the adjacent side is. We have 18.9. So two things. We have the adjacent, right? And we're trying to find the opposite. So we're looking at opposite and adjacent again. So we're looking again at tan theta, all right? And so let's use tan theta. Why? Because we have the adjacent side and we're trying to find the opposite side. Now the opposite side is not 25.2. The opposite side is, because 25.2 is TB, right? The opposite is the missing one, because the opposite is this whole thing, this whole AB, right? That's what we're trying to find, right? And so, yeah, so we need to figure out what is the opposite. Now we know what theta is. Theta is 56 degrees, right? We know what the adjacent is. The adjacent is, we know that because that's 18.9. The opposite is x. And so what we're gonna do, because we're trying to figure out what x is, we're going to put tan of 56 over 1, and this is going to be equal to x over 18.9. We're going to cross multiply. And so we get that x is equal to 18.9 tan of 56. And so what we do here is we multiply 18.9 by tan of 56 degrees, and we get x is equal to 28.0204023. This is our answer, but we have to round. We have to write this correct to 1 decimal place. And so we look at this 2. This 2, since it's less than 5, that means that we cannot round up. And so we keep 28.02 and we leave the rest of the numbers. We eliminate them. And so that means that our answer here is going to be, oh, I'm sorry, we don't round yet. We don't round yet. That's my apologies. We don't round yet because we haven't got an answer yet. All we have gotten was AB. All right. So my apologies. We don't round yet. We keep it the same. So we have x is equal to 28.0204023. And so AB is equal to 28.0204023. Now that we know what is AB, now that we know what is this whole length, all right, remember our goal is to find out AT. This seems small length right there. That's what our goal is, to figure this out. Now we already know the length of the whole thing, which is AB, and we know the length of TB. And so this distance right there. So all we need to do in order to figure what AT is we need to subtract AB and TB. And so that'll be 28.0204023 meters minus 25.2. And when we subtract the 2, we get 2.8204023. Now we could round to correct to 1 decimal point. Notice that this is 2. And so since it's 2, 2 is less than 5. And so that means that we cannot round up. I'm sorry. It's, to 1 decimal place. Yes, so we're correct. This is 2. So since this is 2, we cannot round up because once it's 5 or less, you just leave it the same. You cannot round up. And so that means that our answer is going to be 2.8 because we cannot add 1 more to the 8. So it's just 2.8. And so we eliminate the rest of these decimal numbers. And so we have that AT is going to be equal to 2.8 meters. And that's our answer to this question.